Good morning, everyone. Today I'm going to perform activity 13, and my topic for that is Introduction to Material Science. I am Rohit Tatyasaheb Patil, serial number 54, roll number 19EL042, and I am doing this activity under the guidance of Professor Dr Mangal Dhend. The contents of my presentation are: first is basic introduction to material science, and second is career in material science. The first question arises is, what is material science? Material science is an interdisciplinary field applying the synthesis, characterization and properties of materials to various areas of science and engineering. Material science is the study of properties of materials. It focuses on factors that make one material different from another. Now, I'll tell you four types of materials. First is metals. Second is polymers. Third is ceramics. And the fourth is composites. Now, here's a small video related to basic introduction of material science.
If someone were to ask you what is engineering, what springs to mind? How about a complicated system of parts working efficiently to produce the best possible performance, as in a Formula One engine?
Or do you think about the manipulation of energy to produce sustainable motion, like in a wind turbine?
Then again, you might think about the structural challenges involved with supporting 8 football pitches of glass, such as in the Shard.
Regardless of what you think of, an underpinning factor involved in all of these engineering challenges is the materials used.
Material science and engineering is an interdisciplinary field that uses physics and chemistry with elements of biology. Bridging the gap between science and engineering, material science is used to understand the structure and properties of materials and how we can best exploit them.
It is a science that is truly used for real-world applications. It covers many areas, such as polymers, ceramics, corrosion, and metallurgy. For example,
metallurgy is the study of metals which are formed by atoms arranged in a regular crystal lattice, joined together by a metallic bond. This type of bonding consists of a sea of free electrons which give rise to the metal's characteristic properties. By manipulating the structure of the metals and alloys, it is possible to improve their properties.
This concept is not a new one. For example, blacksmiths from the Middle Ages knew that a metal's properties could be improved by working it with a hammer.
Through deeper understanding of these principles, it is possible to make our metals stronger, tougher, lighter, and more reliable. Industry is constantly developing new alloys tailored for their applications, from aerospace to sports equipment.
Material science and engineering is at the forefront of many technologies, including renewable energy, nanoscience, and spaceflight. It also has an impact on our everyday lives. Products and technologies we take for granted have been made possible through the study and application of materials.
There are still many intriguing and exciting problems to solve. If you are interested in learning more about material science, watch our video on material selection.
Alternatively, if you need no more convincing and you've decided materials is for you, watch our video starting a career in materials.
These are careers in material science.
So you're interested in a career in materials?
Material science offers thousands of exciting opportunities in both industry and research.
Not convinced?
Ever thought about working in space? Both the European Space Agency and NASA have conducted material science experiments in space in order to improve material properties back here on Earth.
Ever thought about helping save the environment? A professor of material science at Penn State University did. He and his research team created a new super absorbent polymer designed to soak up oil, which could dramatically reduce the environmental damage caused by oil spills.
Ever wanted to help people? Scientists are engineering materials for our bodies, creating artificial components such as heart valves, implants, stents, joint replacements, and bone plates from materials such as titanium, polymers, ceramics, and composite materials. Dental applications too.
Ever thought about developing next generation technology? Material science touches all aspects of modern life, and our research is at the forefront of many developing and exciting research areas: sustainable energy, biomedical applications, aerospace, automotive, and polymers.
And we need you.
But where do you start? There are many routes into materials engineering, studying at university being just one of them.
So where can you study? Lots of universities offer material science courses. For more specialised courses, how about Swansea for sports and materials, Imperial Sheffield for aerospace, Queen's Mary for dental, Southampton for ship science, Birmingham for biomaterials.
Each university will have different requirements, but generally to study materials you need 3 A levels, 2 of which being science or maths. UCAS has all the information on all university courses and their requirements.
If studying isn't your thing, how about a modern apprenticeship? Many companies offer apprenticeships as a means of entering into materials. Apprenticeships offer the advantage of working in an industrial environment while earning money and learning. To find available apprenticeships, visit
www.apprenticeships.com or www.gov.uk.
Thank you, all of you, for listening to me, and thank you, ma'am, for giving me this opportunity.